In the last 48 hours, a photograph released to the public changed everything we thought we knew about this interstellar visitor. An image so disturbing that even the most skeptical scientists stopped to reconsider their certainties. The object isn't behaving the way it should. And with each new analysis of this photo, the questions get more and more unsettling. The image captured on November 22nd by photographer Mitsunori Tsumura and released just hours ago shows something astronomers have never seen before. A perfectly straight, ultra-thin tail with edges so sharp they look like they were drawn with a ruler. But here's the part that'll blow your mind. This tail doesn't widen, doesn't curve, doesn't gradually fade like it should. It just cuts off suddenly, like someone flipped a switch. Think about that for a second. Material expelled by a normal comet should spread out, disperse, follow the basic laws of physics we've known for centuries. But that's not what's happening here. How is this even possible? And there's more. Spectral analyses from recent weeks show the object is getting bluer than the sun, a color signature that, so far, defies all conventional explanations about how comets reflect and emit light. The image that changed everything. Let's rewind a bit. What would you normally expect to see in a comet's tail? You'd probably imagine a fuzzy structure, gradually spreading through space, curving slightly from solar radiation pressure and solar wind. Maybe some filaments, some variations in brightness. That's how comet tails work. At least, that's how they've always worked. Tsumura's photograph shows exactly the opposite. The tail is so thin, it looks like a laser beam cutting through space. So straight that engineers would be impressed by the precision. And so defined that there's no gradual transition between tail and empty space. It just ends. Scientists started sending frantic emails as soon as the image was released. Emergency meetings were called. Something wasn't adding up. This wasn't just a weird comet. It was a comet that seemed to be violating the fundamental rules of how matter behaves in space. The three hypotheses being debated. When the scientific community saw these impossible characteristics, three main explanations emerged. Hypothesis 1. Processing artifact. Maybe the image was processed so intensely, long exposures, stacking multiple frames, contrast adjustments, that subtle features were artificially exaggerated, creating the illusion of sharp edges where there's actually a gradual transition. Experts in astronomical image processing warned that aggressive techniques can create this kind of effect. It's possible the tail is actually more diffuse than it appears, but the processing made it artificially defined. But there's a problem. Multiple independent observers, using different telescopes and techniques, are reporting similar features. If it were just an artifact, that shouldn't be happening. Hypothesis 2. Exotic physics of interstellar material. Another possibility is that 3I Atlas is made of materials formed under radically different conditions than those in our solar system. Formed in another stellar system, bombarded by cosmic radiation during billions of years of interstellar travel. The object might contain chemical compounds or physical structures that simply don't exist in native comets. This would explain why the tail behaves so unnaturally. Maybe the material being ejected has unusual electromagnetic properties that keep it collimated. Maybe the chemical composition produces particles that interact with the solar wind in totally unexpected ways. Plausible, but it still leaves unanswered questions about the perfect geometry of the structure. Hypothesis 3. The technological possibility. And then there's the most controversial hypothesis of all, defended mainly by Avi Loeb, a theoretical astrophysicist from Harvard. Loeb compiled a list of statistical anomalies about 3I Atlas. Its nucleus is millions of times more massive than other interstellar visitors while moving faster than them, a combination that, according to his calculations, has less than a 0.1% chance of occurring naturally. He raised a more speculative possibility. The tail maintains its direction because it's being produced by controlled propulsion, not by chaotic ice sublimation. The established scientific community reacted quickly. There's no evidence to justify extraordinary explanations, several researchers said. The object shows typical comet activity, just with unusual proportions. But even the skeptics admitted the data is disturbing. The decisive moment. The real turning point came when astronomers finished fully analyzing the most recent data. The November 22nd image shows a tail extending nearly 9 arc minutes across the sky, equivalent to approximately 4 million kilometers in projected length. And yet, despite this colossal extension, it maintains a uniform width and defined edges. Do the math. If this material were being ejected by normal thermal sublimation, the standard process for comets, it should disperse significantly over that distance. It's like trying to keep a thin, straight water jet at miles away from the hose. Impossible. And yet, there it is. Sharp. Directional. Maintaining coherent structure across a scale of millions of kilometers. Recent spectral data shows the object is progressively getting bluer than the Sun as it moves away, behavior that doesn't fit any known model of cometary spectral evolution. Comets normally get redder as they move away, and activity decreases, not the other way around. This isn't normal comet behavior. It's something different. What this really means, here's what the new observations tell us. If 3I Atlas is a natural comet, it's operating under physics we don't yet fully understand. The combination of impossible tail morphology, anomalous spectral evolution, improbable orbital statistics, and inexplicable photometric behavior creates a puzzle that no single theory can satisfactorily explain. On November 28th, observatories confirmed an apparent magnitude near 10, with the tail structure maintaining its anomalous characteristics even as the object continues moving away from the Sun. We're not saying it's an alien spacecraft, but we are saying this object is forcing us to rewrite what we thought we knew about how interstellar visitors behave. Each new observation doesn't solve the mystery, it deepens it. The window is closing. 3I Atlas passes closest to Earth on December 19, 2025, at a safe distance of about 270 million kilometers. After that, it'll continue its journey back to interstellar space, never to return. This is our only chance, our only opportunity to understand this visitor and what it tells us about the universe beyond our little cosmic backyard. The UN's International Asteroid Warning Network is conducting a global observation campaign that runs until January 27, 2026, using 3I Atlas as a training exercise for planetary defense systems. But the window is closing rapidly as the object moves away and gets fainter. The implications go beyond scientific curiosity. If objects like 3I Atlas are relatively common, and there's evidence they might be, then we're constantly being visited by ambassadors from other stellar systems. Most scientists reject technological explanations. But nobody dismisses the bigger question this raises. What else is out there that we still don't understand? How many other objects like this have gone unnoticed? How many will pass by in the future? The humbling truth. Here's the humbling truth that 3I Atlas teaches us. The universe is far stranger, far more complex, and far more surprising than our current theories can capture. Every time we think we understand the rules, nature shows us there are deeper layers of mystery waiting. The November 2025 photograph doesn't just capture a distant object crossing our sky. It captures the moment we realized, once again, that the universe is stranger than we can imagine. And maybe, just maybe, That's exactly what makes space exploration so vitally important. Because if we don't look up, if we don't pay attention to the visitors passing through our cosmic doorstep, we'll never know what secrets they carry. We'll never understand where we came from, and we'll never discover where we're going. 3I Atlas is leaving. But the questions it raises about alien chemistry, about strange comet dynamics, about what else is traveling between the stars, those questions stay with us. And as we look at the night sky, knowing that something from another stellar system is out there, invisible but real, we're forced to face a fundamental truth. We're not just observing the cosmos is also observing us, in the form of every visitor that passes by, every messenger from distant worlds. What is 3I Atlas really? A comet with extraordinary properties? A phenomenon requiring new physics? Something more? Honestly, we still don't know, and in a way that's the most exciting answer of all.